Hello, brother. How you doing?
Pretty good. How you doing?
I'm doing pretty good, yeah. It's a nice, really nice weather these days, I have to say. So it makes everything nice.
Nuclear fusion on Earth has to be done with slightly larger atoms than hydrogen, since it takes a lot of energy to fuse hydrogen.
Well, let's talk about the elements. So, two small elements. So hydrogen, I didn't know this until recently, but hydrogen itself, just take a hydrogen and hydrogen and trying to make them fuse. It's even more, it's a really, really high temperature. It's a hard thing to do. Plus, like you said, we have to make the hydrogen. It's not readily available. You have to like make it out of something. So what they do is they take isotopes of hydrogen. And there's two common isotopes of hydrogen. One is deuterium, which is H2, and one is tritium, which is H3. And so these isotopes, for some reason, these deuterium and tritium you can make them fuse at a little lower temperature. It's still hot, but it's a little easier than doing two hydrogen atoms. So for us anyway on Earth, not for the sun, but for us here. And so that's what they've kind of centered on was deuterium, or H2, and tritium, which is H3.
However, there is a large supply of one hydrogen isotope and not of the other. How do we get enough atomic fuel to carry out the fusion reaction?
And also, tritium isn't like, hey, let's go down to the drugstore and buy tritium. Okay, it's not around. Okay, it's very rare.
It's not a lot of it around. I think. How much is it? You were telling me there's only like 20 kilograms.
20 kilograms.
They estimate the Earth and stuff,
in the whole entire Earth. Now, to power enough power for people to use, I guess in the world, let's say, it would take 300 grams per day of tritium along with deuterium. And that would use up the world's supply in like a couple months, So that's not a.
Oh boy.
So we got 2 months of unlimited power. Oh, and now we're dead in the water. Okay, so that's not a solution. Tritium is a problem, but deuterium's not. Deuterium's very readily available. It's found in the water, also seawater. It's the isotope of hydrogen, so you can get deuterium fairly simply. It's just having something else to react with that's the problem.
However, there are a few ways to make tritium using other elements on Earth.
So yeah, that's where it comes in. We were doing some research that one way they're thinking of making this tritium is if you combine a couple deuterium atoms, do a nuclear reaction with those, you can make tritium.
That's one thing to do. You can make tritium out of that. Also, there's I think in Europe they're doing lithium. They're splitting lithium, and lithium, you can make tritium out of lithium. So
there's not an inexhaustive supply of lithium.
That's
right?
another problem. Yeah, it's like, well, okay, let's use up all the lithium for this. That's not okay. You also need lithium for a lot of other things. So that's not great. We're already probably overextending ourselves with the batteries we're producing. But
in addition, you can even do fusion reactions with helium-3. It's not really on Earth, but there may be a few ways to make it or get it.
So there's another element you can use, and one company's using that. It's helium-3. Helium-3 instead of tritium, or H3. Helium-3. But do you think helium-3 is prevalent on the Earth?
No, I think you can get on. I heard you can get on the moon though. There's
a lot of it on the moon. I heard
there's a lot of helium-3 on the moon.
So that's another reason why going out into space. Maybe if Elon Musk were to set up this mining operation on the moon,
that would be cool, if he did that or something.
So think about it. You can set up these unoccupied rockets where you got nobody in them, right? Not even an animal, right? You just set them up. Robotic arms. They basically have 20 or 30 canisters. They have small rocket engines attached to them with some guidance systems. You fill it up with the moon dust that's prevalent with He3, and then you blast those back off, come back to Earth, right? And you keep doing that, boom, boom, boom. And you could probably get something going there, that would mine the moon a little bit. But they can make it anyway. Short of that, we'd have to make some here. You can also there's some company that's making He3 as well, right? The same way they're making tritium.
Yeah, I think if you combine two deuterium, you can make helium-3 as well, I think.
So helium-3 combined with deuterium makes another good fusion reaction we can use. Regardless of the two reactions that are available, you get a much larger energy return from nuclear fusion.
So He3 with deuterium fusing, that's a good combination, because those two fuse, that creates He4, helium-4 plus free neutron, and so so the He4 mass is less than, or the difference of mass between deuterium and either tritium or deuterium and He3. And so that's the difference of mass. And it's a huge difference in mass when you talk about percentage-wise. And so that reaction, fusion, is puts out 4 times more amount of energy than the single reaction from fission. Okay.
Nice. Yeah, they're good.
Because you think about the difference in percentage of mass between the two small atoms that create a little bit of a bigger atom, but that's like, maybe 25% change or something like that. Whereas a bigger atom making 2 smaller atoms, maybe like a 5% change or whatever, And so you're talking about, I'm just making those percentages up, but that creates a huge difference in amount of energy that can be put out just from one single reaction. So that's another big advantage of fusion. Well said, brother. Well said.
Yeah.
All right, let's end there. Well, until next time.
All right.